I've got some 6502 processors here, obviously purchased from Hong Kong at some point. I have my doubts. The chips are apparently from week 42 1985, so I don't know, am I to believe that these have been floating around in a factory somewhere since 1985, 35 years? Seems unlikely. So I'm going to try and test them to see if they actually function. But the first thing I'm going to do is I'm going to have a go at wiping the tops, at least one of them, with some alcohol, because the really cheap fake ones the lettering comes off, and as we can see the lettering isn't coming off, which means it's been lasered on, which is a good sign. It stands a chance that these are actually legit. And the other thing that tends to happen is you end up with lots of black on the cotton bud as the paint that is used on them comes off. But these are not coming off. There's no residue on the cotton bud, so there's a reasonable chance that these are manufactured, even if they're not manufactured to the date which is specified on the chips. In the datasheet we can see that there's a NOP instruction, which is about here. No operation, and we can see that the opcode for that's the right term, opcode, I think it is EA. So that will be 11101010, I think. The only other immediately useful information in the datasheet is the pinout. So the circuit I'm going to be using, I've basically nabbed off the internet, of course, and it's basically this. The only difference is that I've added a few pull up and pull down resistors to the data ports because I'm not comfortable with connecting them directly to the power rails. But other than that, this is essentially what I've set up, and of course I've added a switch to the reset button on pin 40. Basically these are the data bus down here, and I've configured them to give the NOP instruction to the processor, which basically means all the processor is going to be doing is stepping through the program counter. So the exact value of the program counter doesn't really matter at this stage, but essentially what it will do is it will do no operation and then it will move on to the next address. I've connected up a little reset switch here which just pulls pin 40 low momentarily, and that resets the processor, so when you power it on you can reset it. These four up here are also connected. This is the power. I don't know why power is there. And then I've got three address bus lines, A0, A1 and A2, which you can see I've connected up to the oscilloscope. This is the power down here coming in. The only other connection is this one here. No, sorry. This one here, which is coming off, this grey one. This is the clock input. So rather than connecting up a 555 oscillator, I've just connected it up to a signal generator. It's currently running at 250 kilohertz. On the left here you can see the signal generator, and you can see in the wave section I've set it to CMOS, which is a 0 to 5 volt waveform. In the frequency, you can see I've set it to 250k. That's not very readable, I know, but it is 250k. And the rest of it is just the defaults. Basically, it's a square wave. You can see the square wave on the yellow trace here because that's the clock signal going into the processor. We know the processor's working because A0 address line, the blue one here, is about half the frequency of the clock speed, which is what you'd expect for a NOP operation. And then we can see A1, the red trace here, that's again half the frequency of A0, and at the bottom you've got A2, which is again half the frequency of A1. So just for giggles really, I've now dropped the frequency of the clock down to 10 Hertz. And I've got to say, I think it's performing adequately. This is now running at 1 megahertz, as you can see on the signal generator. There is a bit of a difference. The signals are not quite as clean as you'd expect. You can see that the rising edge on the address lines are a little bit curved, but this wouldn't really affect operation generally, I would have thought. Well, there you go. This processor works quite happily at 2 megahertz. So we've run it at 10 hertz and we've run it at 2 megahertz. I reckon these chips are legit, you know. I doubt they're 1985 chips. I suspect these are cloned and they're new. Cool.